Hi everybody, welcome back to class. In this little Edpuzzle here, we're going to be working with combining sig figs, scientific notation, and unit conversions. Just to refresh here, just real quick, when we're going through sig figs, remember how many sig figs would be an example like, if my pen would work, in 5,036. This would have how many sig figs? The correct answer would be 4 sig figs. Remember, all non-zeros are significant. That 0 is significant because it's a trapped 0. Then we could look at another example just real quick of 2.0. How many sig figs does that have? The correct answer would be 2 sig figs. The reason being, all non-zeros are significant. This is a right zero, right of the number to the right of a decimal, and that's going, all right zeros are significant. So there's 2 sig figs there. And then the other review thing real quick would be going through scientific notation. How would you write 5,270,000? 5,270,000. What would that look like in scientific notation? When you go through and write that in scientific notation, you would have 5.27 times 10 to the 1, 2, 3, 4, 5, 6. 5.27 times 10 to the 6. The reason it's 5.27, remember, you always want to have, or try to have, one number in front of the decimal there. We want one coefficient there in front of the decimal, unless the rules or what's being asked states otherwise. But one number in front of the decimal there, and then you need to keep the number of sig figs. Well, here we have 3 sig figs, and then the rest of these are not significant because they are trailing zeros. So that's going over just a quick review of significant figures and scientific notation. So let's get into the actual problems. We're going to call this one number 1. We're going to call this one number 2. Right now, what I would like for you to do is go through and solve number 1 right now, keeping the proper number of sig figs. Solve number 1, keeping the proper number of sig figs in your final answer. So when we go through and solve this, we're going seconds to minutes. So we're going small unit to big unit. We're going to be dividing. This is going to be a silly babies dancing problem. So what we have is 5,356 seconds. Put it over 1. And then there are 60 seconds in 1 minute. And that's going to equal 5,356 divided by 60. That equals 89.2666667 minutes. But this is way too many significant figures. So we're going to have to round this at the proper number of sig figs. So there's 1, 2, 3, 4 sig figs. Now remember, whenever we're with significant figures, these conversion factors, so the conversion factors do not play any part in the sig fig calculations whatsoever. Again, the conversion factors, so anything up here, any of those that we plug in, do not contribute to the number of sig figs in a problem. Because the reason they don't is they are exact. Exactly 1 minute equals exactly 60 seconds. Exactly 100 centimeters equals exactly 1 minute. There is no uncertainty. Remember, with significant figures, we're looking at the uncertainty, the accuracy and precision of measurements. So they do not count into significant figure calculations. They work for the math, but not for figuring out the number of sig figs. And this whole problem here is multiplication and division only, so we're going to have to follow the rules where with multiplication and division, we can have the same number of sig figs as the answer as the least number in the problem. And right now, the least number in the problem we're going to have is 4. We're going to have 4. So we go down here, we got 1, 2, 3, 4. So after rounding it to sig figs, we get 89.27 minutes. So there is the proper number of sig figs for our answer. So let's move on to number 2 now. I want you to go through and solve number 2, and I want you, do not worry about sig figs yet. Just go through and solve number 2. When you go through and solve for number 2, what you get is 0.89 years, and you put it over 1. And we go through the conversion factors. We're going years to seconds, so we're going big to small. We're going to be multiplying. This is a bright summer morning. So we have 1 year equals 365 days. 1 day equals 24 hours. 1 hour equals 60 minutes. And then 1 minute equals 60 seconds. And these are all out of the conversion factors up here for time. Equals, and you get 0.89 times 365 times 24 times 60 times 60. Whew, that's a lot. And that equals a number, I'm going to scroll up here. That equals a number of 2806740. 1, 2, 3, 1, 2, 3. So 28,067,040 seconds. That's a lot of seconds. Now, how many sig figs should our final answer have? The correct answer would be 2. We have 2 sig figs here, so our final answer should have 2 sig figs. Here's where scientific notation comes into play. If I would just round this at 2 sig figs, the answer would be 28. Well, 28 is nowhere near the number 28,067,040. So that can't be right. So this is where we're going to use scientific notation. And I want you to write this number in scientific notation, or try to here. And what you actually get here for scientific notation is 2.8 times 10 to the 7th seconds, because 1, 2, 3, 4, 5, 6, 7. The reason we're writing this as scientific notation is 2.8 times 10 to the 7th is going to be the same number of decimal places if you would take 2.8 times 10 to the 7th. These numbers here, we don't know those. We're not exact enough here with our sig figs. So this is how we are going to write it. In scientific notation, a really big number like that. We'll be writing it like this in scientific notation with the proper number of sig figs. So let's move on to another problem now. We're going to call this one number 3, and this one down here number 4. I want you to go through and solve number 3 now. And then round it at the proper number of sig figs. Round it at the proper number of sig figs. When you go through and solve this problem, you get 784,400, put it over 1. That's too big of a line there. So this is going to be seconds. So what we have is we're going from small to big. So we have a silly babies dancing here. So we have 60 seconds equals 1 minute. 60 minutes equals 1 hour. 24 hours equals 1 day. And then 365 days equals 1 year. All the hours, minutes, seconds, they all cancel, and I forgot to do that up here earlier. These all cancel out. And you get 784,400 divided by 60 times 24 times 365. Again, that's a lot. So the final answer would come out to 0.0248731,608 years. When we round it at the proper number of sig figs, though, it comes out to be 0.02487. Reason being, 1, 2, 3, 4 sig figs, 1, 2, 3, 4 sig figs. These are not significant because they are trailing zeros. Now what I want you to do, we have years. I want you to take this final answer, 0.02487, and I want you to write it in scientific notation now. I want you to write that number in scientific notation. The final answer after writing in the scientific notation is going to be 2.487 times 10 to the negative 2 years. And we got to keep all of our sig figs, remember, and we're just moving the decimal place now, 1, 2. So it's going to be to the negative 2 because we're going to the right here. Let's move down to our last problem. Go through and solve number 4 now. Well, with number 4, we get 7.34 centimeters cubed over 1 times, we're going to get 1 centimeters cubed equals 1 milliliter according to our conversion factor here. Multiply again, and you're going to get 1,000 milliliters equals 1 liter equals centimeters cubed cancel, milliliters cancel, equals 7.34 divided by 1,000 equals 0.00734 liters. And we have 1, 2, 3 sig figs, 1, 2, 3 sig figs. According to the rules for multiplication and division, we have the correct number of sig figs. What I want you to do now is write this answer in scientific notation. I want you to write this answer in scientific notation. The correct answer for scientific notation is 7.34 times 10 to the negative third liters. Again, we're moving this to the right, and remember, we go to the right, we're going to have a negative exponent there. So we get 7.34 times 10 to the negative third liters. Hopefully this helps you out a little bit with scientific notation and sig figs. I'll continue to provide you with practice like this. You will have a quiz coming up very soon, and I will announce that for you. Everybody have a wonderful day. Bye-bye.